Hey guys, welcome to another Packet Tracer activity. This video we will, let me resize the window here. This video we will be observing web requests. So the objective here would be view the client server traffic from PC to a web server when requesting web services. So step one is to verify connectivity to the web server. So we're going to click this guy here, go to the desktop and open the command prompt up. I'm going to go ahead and ping the Cisco Learn server .web.com. We're going to wait for a reply. Awesome. Now we're going to go ahead and open up our web browser and actually connect to the actual server. So we will type Cisco Learn.web.com. It brings up the website on that server, which is welcome to the Cisco Learn Web Center. We'll go ahead and read it here. Learn about web client server interaction. When a web client enters the website name into a browser, the name is resolved by a DNS or a domain name server to an IP address. Once the client receives the IP address, the client browser uses that IP address and port 80 to request the web service. This request is sent to the server using Hypertext Transfer Protocol, or HTTP. When the server receives the port 80 request, the server will respond to the client request by sending a web page to the client. The information content of this web page is encoded in a specialized markup language. HTML, or Hypertext Markup Language, is a popular language used and is currently used with this web service. However, other languages also exist, such as XML and XHTML. These are gaining popularity. Some of the things that HTML coding can do is bolding, italics, underlining, and colored fonts, as well as headers of different sizes. Alright, interesting. So we're going to go to where we got the web page from, and we're going to go ahead and display the HTML code itself by going to the config and the HTTP tab. There we go. Alright. So you see a whole bunch of coding here, and let me re-grab that this guy here, and we can compare the coding to what it says. So as you can see, center, font size 2, color blue. Oh, let me bring it down here. Welcome to the Cisco Learning Center. Awesome. So we have our H1 and H2 or H2 header here, which is Learn Web Client Server Interaction, and they have a whole bunch of typing here, which is I was actually looking at the code here, and there's actually an error in the code because there's no paragraph tag or anything, so the browser wouldn't be sure really what to do with it if this were an actual website. But the BR is the break commands, add lines and stuff. The P command will also do that as well. And as you can see, some of the things that HTML coding allows us includes break, BR would include, so that would be the break, bolding, italics, underlining, and colored font, as well as headers of different sizes, H1, H2, and H3. Alright, perfect. Alright, so next we're going to observe the traffic between the external client and there. So we're going to enter our simulation mode here. We're going to edit our filters. We only want HTTP and TCP, perfect. Then we're going to create an advanced PDU. We're going to view the traffic on how they talk. So we're going to go ahead and click as the source, and then that is the destination. Alright, we're going to change this to HTTP here. Go ahead and click that destination one more time. Our starting source port will be 1000 here. The starting port doesn't really matter. It could be any value except for the ones that are like mainly used. It's a destination port that uses it. So when a request for like an HTTP or a web page is sent, the destination port will always be port 80, and the server listens on that port and then responds. and then they move the conversation to another port, like port 1000, so other users and hosts can request web pages as well. Okay, so we're going to type this to 120 seconds here, and we're just going to observe. Create the PDU, and we're going to, I have this on super fast mode because it takes a while. So as we, that's weird, it shouldn't have sent that there. So as we watch the messages bounce back and forth, so many packets are being sent back and forth because when oh yeah, it was supposed to I guess supposed to send it there to get the table for this computer. So yeah. Anyways, back to what I was saying. Awesome, that didn't take as long as it usually does. So if you look here, all these events are different packets being sent back and forth, and there are so many of them because a TCP connection requires a packet to be sent and then an acknowledgement packet to be sent back to the host computer, which that's TCP. UDP is the other one, and that's mainly used for like gaming or voice over IPs, and that's when the packets are just sent one way and there's no acknowledgement required. Alright, thanks. This has been another Packet Tracer activity on observing web requests.